Alrighty, we're going to look at trigonometric ratios today. In order to look at these trig ratios, we have to have a right triangle. And if you recall from earlier or previous years, a right triangle is going to have one 90-degree angle, that's our right angle, and then two acute angles. So here's just a really generic triangle. All of our angles are labeled with capital letters, and then the sides are opposite of the angle, and they're labeled with lowercase letters. So here's capital A, that means angle A. Side length A is across the triangle. Angle B, side length B. Angle C, side length C. Okay, so little c, angle C, is what we call the hypotenuse. It is the longest side of our triangle, and it will always be across from that 90-degree angle. So I'm going to introduce three trig ratios today. So the first one is going to be sine. We abbreviate it SIN. And in a triangle, we're going to be comparing the opposite side to the hypotenuse. And it'll always be sine of a particular angle. So that'll be explained in a minute in our next example. But sine is always going to be opposite over hypotenuse. And if you look at these letters, we have an S, an O, and an H, which is where we get so. This will help you easily remember these fractions. Next one is cosine, and we abbreviate it COS. So cosine is the adjacent side, which means right next to, over our hypotenuse. Again, we have C for cosine, A for adjacent, H for hypotenuse, which gives us the C. And then tangent is abbreviated TAN, and it is the opposite side over the adjacent side. TOA gives us TOA. So really easy way to remember sine, cosine, and tangent is SOHCA, TOA. So here's an example. We have a right triangle. We have side lengths 5, 12, and 13. Again, 13 is our hypotenuse because it's across from our right triangle, or excuse me, our right angle, and it's also the longest side in our triangle. So we're going to find some trig ratios. The first one is sine of B. Well, sine is so opposite over hypotenuse. Here's angle B. The opposite side means I have to move across my triangle. So 5 over our hypotenuse, which is 13. So sine of B is 5 over 13. Cosine of B. Okay, again, here's, there is my triangle. Angle B, cosine is C, so adjacent over hypotenuse, and adjacent means right next to. So adjacent would be 12. Hypotenuse is 13, so our trig ratio for cosine of B is 12 over 13. Tangent is TOA, so opposite over adjacent. Again, we're still working with angle B. Opposite of B would be 5. Adjacent to B is 12. So tangent of B comes out to be 5 over 12. And I'd like you guys to answer, what is cosine of A? So now you're using this angle. Tell me, what is cosine? Okay, a couple more things. Sometimes we won't have all three side lengths, and in a right triangle we can use what we call the Pythagorean theorem to help us find a third side length. So Pythagorean theorem is a squared plus b squared equals c squared. Remember, c squared is always that hypotenuse. So here is our triangle. Notice we are missing this side length, so we can go ahead and solve for little a. Well, we know a squared plus b squared, b is 4. So a squared plus 4 squared equals our hypotenuse squared. Simplify 4 squared and 5 squared. I'm going to subtract this 16 to the other side. So now I have a squared equals 9. And if you take the square root, you get a equals 3. So now I redefined our triangle. And now I have a equaling 3. And now I'm going to find some trig ratios. So sine of A, again, sine is so opposite over hypotenuse. Here's angle A. Opposite is 3. Hypotenuse is 5. 3/5. Cosine of B, we can always change up this angle. You won't ever use the right angle though. So cosine of B right here, cosine is adjacent over hypotenuse, so 3/5. And then I want you guys to find tangent of A.